Calling parent class underscore init underscore with multiple inheritance, what's the right way? Say I have a multiple inheritance scenario. There's two typical approaches to writing C's underscore init underscore. Old style, parent class dot underscore init underscore self, newer style, superderivative class, self, dot underscore init underscore. However, in either case, if the parent classes, A and B, don't follow the same convention, then the code will not work correctly. Some may be missed, or get called multiple times. So what's the correct way again? It's easy to say just be consistent, follow one or the other, but if A or B are from a third-party library, what then? Is there an approach that can ensure that all parent class constructors get called, and in the correct order, and only once? Edit, to see what I mean, if I do. Then I get. Note that B's init gets called twice. If I do, then I get. Note that B's init never gets called. So it seems that unless I know/control the inits of the classes I inherit from, A and B, I cannot make a safe choice for the class I'm writing, C.
Both ways work fine. The approach using super leads to greater flexibility for subclasses. In the direct call approach, C._init_ can call both a ._init_ and B._init_. When using super, the classes need to be designed for cooperative multiple inheritance where C calls super, which invokes A's code which will also call super which invokes B's code. See this URL for more detail on what can be done with super. Response question as later edited. So it seems that unless I know/control the inits of the classes I inherit from, A and B, I cannot make a safe choice for the class I'm writing, C. The referenced article shows how to handle this situation by adding a wrapper class around A and B. There is a worked out example in the section titled How to Incorporate a Non-Cooperative Class. One might wish that multiple inheritance were easier, letting you effortlessly compose car and airplane classes to get a flying car, but the reality is that separately designed components often need adapters or wrappers before fitting together as seamlessly as we would like. Smile. One other thought: if you're unhappy with composing functionality using multiple inheritance, you can use composition for complete control over which methods get called on which occasions.
The answer to your question depends on one very important aspect. Are your base classes designed for multiple inheritance? There are three different scenarios. The base classes are unrelated, standalone classes. If your base classes are separate entities that are capable of functioning independently and they don't know each other, they're not designed for multiple inheritance. Example: important, notice that neither foo nor bar calls super._init_. This is why your code didn't work correctly. Because of the way diamond inheritance works in Python, classes whose base class is object should not call super._init_. As you've noticed, doing so would break multiple inheritance because you end up calling another class's _init_ rather than object._init_. Disclaimer: avoiding super._init_ in object subclasses is my personal recommendation and by no means an agreed upon consensus in the Python community. Some people prefer to use super in every class, arguing that you can always write an adapter if the class doesn't behave as you expect. This also means that you should never write a class that inherits from object and doesn't have an _init_ method. Not defining an _init_ method at all has the same effect as calling super._init_. If your class inherits directly from object, make sure to add an empty constructor like so. Anyway, in this situation, you will have to call each parent constructor manually. There are two ways to do this. Without super. With super. Each of these two methods has its own advantages and disadvantages. If you use super, your class will support dependency injection. On the other hand, it's easier to make mistakes. For example, if you change the order of foo and bar, like class foo bar bar foo, you'd have to update the super calls to match. Without super you don't have to worry about this, and the code is much more readable. One of the classes is a mixin. A mixin is a class that's designed to be used with multiple inheritance. This means we don't have to call both parent constructors manually, because the mixin will automatically call the second constructor for us. Since we only have to call a single constructor this time, we can do so with super to avoid having to hard code the parent class's name. Example. The important details here are: the mixin calls super._init_ and passes through any arguments it receives. The subclass inherits from the mixin first, class foo bar foo mixin bar. If the order of the base classes is wrong, the mixin's constructor will never be called. All base classes are designed for cooperative inheritance. Classes designed for cooperative inheritance are a lot like mixins. They pass through all unused arguments to the next class. Like before, we just have to call super._init_, and all parent constructors will be chain called. Example. In this case, the order of the parent classes doesn't matter. We might as well inherit from kookbar first, and the code would still work the same. But that's only true because all arguments are passed as keyword arguments. Using positional arguments would make it easy to get the order of the arguments wrong, so it's customary for cooperative classes to accept only keyword arguments. This is also an exception to the rule I mentioned earlier. Both kookfoo and kookbar inherit from object, but they still call super._init_. If they didn't, there would be no cooperative inheritance. Bottom line, the correct implementation depends on the classes you're inheriting from. The constructor is part of a class's public interface. If the class is designed as a mixin or for cooperative inheritance, that must be documented. If the docs don't mention anything of the sort, it's safe to assume that the class isn't designed for cooperative multiple inheritance.
Either approach, new style or old style, will work if you have control over the source code for A and B. Otherwise, use of an adapter class might be necessary. Source code accessible, correct use of new style. Here, method resolution order, row, dictates the following. CA, B, dictates of first, then B. Row is C, A, B, object, super A, self, dot underscore init underscore, continues along the row chain initiated in C dot underscore init underscore, 2, B dot underscore init underscore, super B, self, dot underscore init underscore, continues along the row chain initiated in C dot underscore init underscore, 2, object dot underscore init underscore. You could say that this case is designed for multiple inheritance. Source code accessible, correct use of old style. Here, row does not matter, since a dot underscore init underscore and b dot underscore init underscore are called explicitly. Class CB, A, column would work just as well. Although this case is not designed for multiple inheritance in the new style as the previous one was, multiple inheritance is still possible. Now, what if A and B are from a third-party library, i.e., you have no control over the source code for A and B? The short answer, you must design an adapter class that implements the necessary supercalls, then use an empty class to define them row. See Raymond Hettinger's article on super, especially the section, How to Incorporate a Non-Cooperative Class. Third-party parents, A does not implement super, B does. Plus adapter implements super so that C can define the row, which comes into play when super adapter, self, dot underscore init underscore, is executed. And what if it's the other way around? Third-party parents, A implements super, B does not. Same pattern here, except the order of execution is switched in adapter dot underscore init underscore, super call first, then explicit call. Notice that each case with third-party parents requires a unique adapter class. So it seems that unless I know/control the inits of the classes that I inherit from, A and B, I cannot make a safe choice for the class I am writing, C. Although you can handle the cases where you don't control the source code of A and B by using an adapter class, it is true that you must know how the inits of the parent classes implement super, if at all, in order to do so.
As Raymond said in his answer, a direct call to the dot underscore init underscore and b dot underscore init underscore works fine, and your code would be readable. However, it does not use the inheritance link between C and those classes. Exploiting that link gives you more consistency and make eventual refactorings easier and less error-prone. An example of how to do that.
If you want to see more, please consider subscribing.